The title of this note is Composite Functions, and the outcome is how do I determine the domain of a composite function? A composition of functions, there's a couple of notations that we're going to see. The first looks like this. This is read f of g of x. And the idea is that we're going to be putting a function g into a function f. So we're taking the function of a function. Another way that you will see this notated is you will see f of g, and it's a little o right in the middle. It's not on the line like the f and the g are. It's in between the two lines if you're writing on lined paper. So f of g of x is another notation that you're going to see. Okay, so how do you actually compose two functions? So you're going to write the outside, let's just say outside function, using placeholder notation. So in the example above, the outside function is f. F is on the outside, and g is on the inside. And placeholder notation just means you're going to put a blank everywhere where there's an input. Then you're going to put g of x into the blanks. And then you're going to simplify as much as possible. So we're going to look at an example of this here. Okay, what about the domain? The domain of a composite function. In f of g of x, the output of g becomes the input of f. And so I have a graphic here, and you're going to see this graphic a lot. Every time I ask you about domain, you're going to make this graphic. So we have the domain of g here, and whatever you put into g, it's going to go through the g function. Think of this like a machine. So whatever input you have here, it's going to change, and it's going to become g of x. And then it's going to go through the f machine, and it's going to become f of g of x. This becomes the input of f. So when we're thinking about domain, we want to think about what values are excluded from the domain. First things first, you're going to eliminate any values that are not in the domain of g. Those values are excluded. Secondly, you're going to set g of x equal to any values that are not allowed in f and solve for x. Those values are also not in the domain of the composite function. Let's look at an example. We have two functions, f of x equals 1 over x minus 2, and g of x equals the square root of x plus 3. So we're going to compose these functions. We're going to find f of g of x. So following our steps, we are going to write the outside function f with placeholder notation. So f of blank equals 1 over blank minus 2. Everywhere where there is an input x, we've left a blank. Step 2, we're going to put into the blank g of x. And so g of x is equal to the square root of x plus 3. So we have f of g of x equals 1 over, and g of x, we're going to replace that with the square root of x plus 3, and then minus 2. So this is the composite function, f of g of x. We would simplify it if at all possible, but there's nothing to simplify here because you can't subtract something that is outside of a radical with something that's inside. So there's nothing to do. So that is the composite function, f of g of x. So then our next piece of this is to figure out the domain. What is the domain of this function here? So first, I'm going to go back so we can see these. First, we're going to eliminate any values that are not in the domain of g. So g is this function, the square root of x plus 3. Well, what can you not take the square root of? You cannot take the square root of a negative number. The smallest number you can take the square root of is 0. So what's the smallest value in g going to be? It's going to be negative 3. And here's how I can do that algebraically. I know that g of x equals the square root of x plus 3. And the lowest that that can be is 0, sorry. This should be greater than or equal to. Because this can be positive, and it can equal 0. It just can't go below 0. So what I'm going to do is I'm going to solve. I'm going to square both sides. So x plus 3 is greater than or equal to 0. Subtract 3. This is my domain. Everything greater than or equal to negative 3. If I think about it as a number line, here's negative 3. Negative 3 is allowed in the domain because negative 3 plus 3 is 0. And I can take the square root of that. And everything greater than negative 3 is allowed in my domain. So the domain of g is from negative 3 to infinity. So everything less than negative 3 is excluded. Going back to step 1, eliminate any values that are not in the domain of g. Everything less than negative 3 is not in g. So the domain of this composite function also excludes values less than negative 3. So right now it would seem that this domain is the domain of the composite. But we have an extra step to look at. We have to consider this middle step here. We have to set g of x equal to values that are not in the domain of f. So here's f. F is 1 over x minus 2. I'm going to scroll down and rewrite that. F of x equals 1 over x minus 2. What value is not in this domain? We're dividing. The only thing we cannot divide by is 0. That denominator equals 0 when x is 2. So x is 2 is excluded from the domain. I'm going to go to the picture. This is the domain of g. Then I'm going to go through the g function, and then I'm going to go through the f function. And we already said that the domain of g is everything from negative 3 to infinity. Well, what about f? The domain of f excludes 2. So we need to make sure that the output of g, that one of these inputs, does not have an output of negative 2. Because if it has an output of negative 2, it's not going to be able to go into the f machine. So what we're going to do is we're going to set the g function equal to 2. So square root of x plus 3. When does it equal 2? Because when it equals 2, it will break the second part of the machine. It will break the f part of the machine. So solving this, we're going to square both sides. X plus 3 equals 4. Subtract 3 from both sides. X equals 1. X equals 1 is not allowed in the domain. Because if x were to equal 1, even though 1 is in between negative 3 and infinity, even though 1 is allowed here, if we input 1 into g, the output will be 2. And then if we go to try to put into f, we'll have 1 over 2 minus 2, which would be 1 over 0, and it will break the machine. So the domain is from negative 3 to infinity, excluding 1. So going back to our picture, negative 3, it includes negative 3, but when we get to 1, we're going to have an open circle. So the domain includes negative 3, goes to infinity, but we had to take out 1. So we're going to write that in interval notation. There are 2 intervals, 2 shaded sections. So the first interval goes from negative 3 to 1, but it does not include 1, so we're using the round parentheses. And the second interval goes from 1 to infinity. This is the domain of the composite function. The domain piece is really tricky. We are going to spend a lot of time practicing this. This is the end of our notes, so go ahead and draw your line for your summary and come into class ready to practice domain.